Hello students, here I have come up with one more challenging problem on electrodynamics. The problem is like this. The problem is we are making a current loop, a rectangular loop of wire, an AC generator. I mean, I will be getting an AC generator out of nothing. A coil, a rectangular coil. I will make an AC generator out of this rectangular coil. Not by rotating it, nothing. Just a rectangular coil. So, a current loop a wire loop as an AC generator. तो ये करंट कैरिंग वायर है, एसी करंट यहां से जा रहा है, ट्रांसमिशन लाइन समझो, ये एसी करंट इस वायर में से जा रहा है. ये जो वायर है इट कैरीज एसी करंट, बट इन द विसिनिटी देयर इज अ करंट लूप, देयर इज अ रेक्टेंगुलर वायर लूप, a conducting wire loop. It does not carry any current, no, not at all, but it is a loop. And what I will prove, or what I will do, I will make this loop as an AC generator. It generates AC, this one. If you take connections, cut it here and take two connections, it will be supplying AC voltage to you without rotating it, without doing anything with it. Have a look. So the basic is this wire carries a current. I is equal to I0 sine omega t, and in the vicinity I place a loop, a wire loop, not a current loop. It does not carry any current initially, no, nothing. It is just a loop, right? And here is a current carrying conductor, and this loop is in the magnetic field of this current carrying conductor. ये current carrying conductor है और ये इसके magnetic field में आ गया. तो मैं देखना चाहूंगा, because this current is changing, therefore it will change the magnetic field here. It is magnetic field is that's inwards. Here it is inward magnetic field. Because of this current loop, the plane of because of this wire, the plane of the loop is such as the magnetic field goes inside. So can we find somehow the flux through this loop? What is the flux through this loop of the magnetic field which enters this loop due to this current carrying conductor? This current carrying conductor produces magnetic field here. I have to find the flux through this complete loop. Okay, let me find, because the magnetic field does not remain constant in this direction if you go away from the wire. Therefore, magnetic field from here to here is space variable. Also, that may be time variable also, because it is current is varying in time. First of all, let me find the flux. Small flux d phi is equal to this part of the wire loop, small part of the wire loop, which is at a distance of r from the wire, and it is width is dr. So how much area is this? So it is B, magnetic field due to this wire here on this patch, into what? B into, no, not B, L into dr. L is this length and dr. So it is L dr. This is flux. Small amount of flux through this. But I have to find flux from here to here. Right? So it is, okay, d phi. What is magnetic field of this here at this point? That is mu 0 I divided by 2 pi r L dr. I have supposed the magnetic field of this wire here at this point, because that is the magnetic field which crosses this. Right? So what is d phi? That is mu 0 L. Okay. What is I? That is I0 sine omega t by 2 pi r. L is here, I0 sine dr. Now integrate both sides to find the total flux. Integrate, and here I will integrate. So it is phi equal to, how much is that? Mu 0 constant, L constant, I0 constant, sine omega t will not integrate because we are integrating over r. So divided by 2 pi, and you are integrating over r from wire to wire, from A to this point. So that is A to A plus B. A to A plus B. Right? So we are somewhere closer to finding the flux through this wire loop. इस wire loop में से कितना flux in कर रहा है? We are somewhere very close to finding that. So why not to do this thing in more detail? Have a look. So it is flux is equal to, it is mu 0, okay, L, it's I0, maximum current, sine omega t whole divided by 2 pi ln of r under a to a plus b. That will be equal to okay, phi equal to mu 0 L I0 sine omega t divided by 2 pi ln of a plus b minus ln of a. This will be phi equal to mu 0 L I0 sine omega t divided by 2 pi ln of a plus b divided by a as per the rules. Okay, now this is the total flux which passes through this wire loop, total flux. But now see here, this total flux is a function of time, sinusoidal function of time, right? So when it is sinusoidal, that means flux through the loop changes. So when the flux through the loop changes, there is induced EMF. And interestingly, that induced EMF will be alternating, because this will now become an AC generator. This is alternating. How? Differentiating both sides. Differentiate both sides. What we get? d phi by dt is equal to constant जो है उनको differentiate करने की जरूरत नहीं है, L I0 by 2 pi ln of a plus b by a. तो डिफरेंशिएशन ये होगा sin ओमेगा t. बाकी कांस्टेंट है, रखो कांस्टेंट्स को. ये कांस्टेंट है यहां से यहां तक mu 0 L b I0 b और ln of a plus b by a b 2 pi. तो यहां इसका डिफरेंशिएशन होगा cos ओमेगा t into omega. Omega is multiplied here. So it is nothing but induced EMF. ये वाला, it is induced EMF. It is induced EMF. This one, d phi by dt. It is mu 0, okay, L I0 by 2 pi. पर ओमेगा पहले लाइए यहां पर, और ln of a plus b by a cos omega t. ये है alternating voltage source. So this is voltage source which alternates in time. It is as good as AC source because cos omega t is alternating. At t is equal to 0, cos omega 0 is 1, so we have the maximum voltage at t is equal to 0. But after time, the voltage will decrease and then it will increase. So it will alternate because it's a cos function. So what we have done is an excellent example. It's a current carrying conductor, and in the vicinity we just place a loop. A wire loop, a rectangular wire loop. You can put a circular wire loop. It's just a loop in a proper orientation. Of course, the proper orientation must be proper so that magnetic field enters this. So, but the current here is changing in time, and when current is changing, the flux through this loop will change. When the flux through the loop will change, that will produce induced EMF. But interestingly, that induced EMF is alternating. So we have generated a alternating AC source from a current carrying conductor, and you have AC current through the wires. Just place a loop, not a current loop, just loop. A loop in its vicinity, it will become a alternating voltage generator for you. Thank you. This was one more problem for you, but I will continue with the series. Thank you.